Hi everyone, welcome to DMR tutorials. Three students, one from KV Schools Pune, second is Bharati Vigyan Bhavan Schools Chennai, and third is from Arkids International School Bangalore. These three students put a similar type of doubt in my website to clarify the doubt, and three students asked the similar type of doubts. They know the answers, but they don't know how the teacher comes to the conclusion. They need the explanation for that answer. So I am very glad to explain those answers in a systematic way. So to answer the question given by those people, first we need to understand a small concept in 10th class mathematics. Name of the lesson is circles, and that is linked to the question what they have asked. So the theorem in 10th class circles lesson is, suppose this is the circle, this is the center of the circle, and say this is the tangent, and this is the center O, it is a point of contact P. And the theorem says that the angle between the normal at P, O, if you join PO, angle between the radius and tangent is always 90 degrees. Angle between radius and the tangent is always 90 degrees at the point of contact. This is the theorem, and the proof and verifications of this theorem you are going to get in your mathematics portion under the circles lesson. But that theorem is useful right now. Now what the question asked by them? If a ray of light incident on a concave mirror with an angle of incidence 30 degrees, what could be the angle between the reflected ray and the principal axis? In the case when the ray of light is passing parallel to the principal axis, when the incident ray incident on the pole, when the ray of light passes through focus. In three different cases, what could be the angle between reflected ray and the principal axis? This was the question asked by them. The first in the list is, this is the concave mirror, focus and center of curvature. The incident ray, the first incident ray is passing parallel to the principal axis. So this is the incident ray, which is parallel to the principal axis. Let it be A and B. Now let us assume a tangential plane at the point of incidence. B is the point of incidence. Let us assume a tangential plane at B. This is the tangential plane assumed at the point of contact B. Now, and of course the line joining the center to the point on the surface is nothing but the radius. It is a radius, and this is the normal. Radius is normal to the tangential plane, and according to the definition of angle of incidence, the angle between incident ray and normal is nothing but angle of incidence. This was given as 30 degrees. And when the ray of light is passing parallel to principal axis, incident ray, the reflected ray passes through focus. This is the reflected ray. We know that angle of incidence is always equal to angle of reflection. This is also 30 degrees. So the full angle between incident ray and reflected ray is nothing but 30 plus 30, that is 60 degrees. Now, these two, incident ray and principal axis, are parallel, and take this as the transversal. BF is the transversal, and these two, this angle and this angle, that is angle ABF and angle BFP are alternate interior angles which are equal. So if this is 60, this is also equal to 60 degrees. And that is the answer. The angle between reflected ray and principal axis is 60 degrees. So this is the first case, when the ray of light is passing parallel to the principal axis. The second case it was asked is, if the ray of light is passing through the focus, FA is the incident ray, AB is the reflected ray, and CA is the radius. If you have taken a tangential plane, CA will be the normal to the plane. So this was given 30 degrees angle of incidence, and this also will be same 30 degrees. Angle of incidence is equal to angle of reflection. And now this full angle is 60 degrees, and this angle, these two are alternate interior angles, so this is also 60 degrees. So in this case also, in the second case, when the ray of light is passing through focus, in that case also, the angle between reflected ray, this is the reflected ray and this is the principal axis. Reflected ray, principal axis are parallel. Now, what is the angle between two parallel lines? Angle between two parallel lines is 0, or you can take undefined. So here the answer will be 0, even without drawing the diagram also. And this is the principal axis, reflected ray, parallel, angle between the parallel lines is taken as 0. So here final answer is 0. Here the angle between reflected ray and the principal axis is 60 degrees. Now what is the third case they asked? The third case is, here you assume a tangential plane, CP is the radius, and this itself is the normal, AP is the incident ray, which is 30 degrees, and the incident ray turns back with the same angle. So the angle between principal axis and reflected ray, here it is again 30 degrees. So in different cases the answer is different. So in the first case, in the case of a ray of light passing parallel to the principal axis, the angle between reflected ray and principal axis is double to the angle of incidence. In this case, the angle between reflected ray and principal axis is 0. Here the angle between incident ray, angle between reflected ray and principal axis is 30 degrees, which is equal to the angle of incidence. So this is about the 3 cases that they have asked. The basic principle involved is this is angle between tangent and radius is always 90 degrees normal. So in case if you have any doubts related to maths, physics, chemistry, anything, you can put the note in my website, and I'll check that and I'll respond soon. Thank you very much, and I'm signing off.